Yeah, so just, yeah, so it's about VTK-based in situ visualization in Julia. I have some duties in doing numerical math and PD-based simulations and so on, and I have a secret interest in visualization. And it's kind of in situ visualization, which means that I have a simulation code which runs on 1, 2, or 3D structured or unstructured grid. We have a PD solver running kind of time-dependent simulations, and I want to see what it's doing. And so I want to plot the output during the simulation run. I want to have a non-intrusive API, so it can be added to any kind of code I write. And I want to use the 3D hardware, the GPU hardware. Yeah, so. And I did many attempts on this kind of stuff. So hello Joseph, I started with GKS, yeah, in early times. Then I wrote some kind of C library which uses X Windows in GMS, and then I switched to OpenGL. And we did lots of things based on OpenGL fixed function pipeline OpenGL. And just lately I switched to try to figure out what can be done with VTK. So I put some of the old stuff on GitHub for whatever reason, and and we also may make something of this available also for Julia if we find time. Okay, so VTK. So I was scared by the news that the fixed function pipeline of OpenGL is deprecated because, in fact, the API of this is really easy to use and very, very intuitive. So you just, it's very easy to figure out how to just draw a triangle, line, a point, and some characters. And based on this, you can just set up quite complex visualization stuff also for 3D. And I didn't want to start messing around with shaders, Vulkan, or wherever this goes. But the point is that I'm seeing that there are very few intermediate level interfaces for 3D graphics or for GPU graphics available. So, which is a big pity, and it's not only true for Julia, but for the whole kind of scientific computing visualization. The only good interface I'm seeing, besides of course of GR, is 3.js, and this uses WebGL but it's bound to the browser, and there's nothing equivalent as far as I know for C++. And that's, by the way, a big chance of for Maki also to make a dent outside of the Julia community, yeah? Because if you're everyone in this kind of community who is doing 3D simulations is using ParaView, yeah? Or maybe Visit. So just as I said something now about ParaView, ParaView just uses VTK as its library backend, and VTK provides lots of high-level primitives for grid database visualization. So why not to try this? So VTK also has a kind of long history. It started in '93 already, and has a BSD license. From my point of view, though it has quite some legacy edges in the design and how it's to be handled, it's very well maintained. So they have a modern OpenGL. They are somehow trying so there are discussions about Vulkan support. So it's not really clear if it will be there, but I have some hope. So they switched, for instance, from bare pointers to smart pointers. They're starting by using C++11 features. So they're kind of evolving, besides, of course, of more functionality, they're evolving their code. And so it's kind of well maintained. And it's a first-class citizen in the CMake universe because both CMake and VTK are maintained by the same kitware company. So essentially, it compiles quite well. So. Yeah, as I said, it's a library behind ParaView, Visit, and so on. Lots of US labs use this for high performance computing things. And so I think there's a big interest in keeping this going. And the investment in learning this appears to be rather safe. Some cons, there are lots of examples which are kind of hard to learn. So the structure, which if you use the bare VTK API, it's not so easy to use. In particular, their way of using the event loop is hard to incorporate into simulation codes. Just XY plots are quite ugly, so that's really hard to. That's the reason, of course, why I use other plotting things just my 1D plots, yeah, and it's really huge. So it's more than 5,000 or 7,000 files to be compiled if you just compile the full thing. And I kind of figured out how to minimize this to around 2,000 files to be compiled. Yeah, if you just by some CMake options. So in that sense, it's hard to use. But what I then did before I started working with Julia, I started. Okay, so VTK has the basic structure is like we have the VTK dataset data structure, which just contains grids, point scalars, vectors, and so on, and which essentially more or less maps what you would write into a VTK file. And you just fill this data set and then you can do something with it. And what you can do is you can create a rendering pipeline by chaining various filters to extract isolines, apply colors, or whatever you want to do, which is kind of similar with Maki's Lift kind of things, because you just create kind of pipelines doing something with the data. And essentially, these pipelines are what you also create if you use PowerView. You have to kind of click together in the GUI and what you want to see. And then you have the possibility to do this, to set up these pipelines just in the C++ code. You just have some structure part of the, which has an output port. You connect this to an input port of the next one, and then the data are processed in this way. By the way, it seems that with modern parts of VTK, you're also not completely bound to filling a data set and to double your data. But at the other hand, this gives the possibility, I come back to this in the next slide, that you can essentially put this into an extra rendering thread. So then once you have kind of your pipeline, you can create so-called actors, which then kind of map things to the screen. Yeah? So that's this kind of basic structure. And what I did is, so you are very flexible with these pipelines. You can have different pipelines. You can kind of script them also in Python or whatever. And what I did was to make VTKView, which is essentially VTK viewer, which is based on a selection of its fixed rendering pipelines for standard visualization tasks. So I have a figure class and some derived classes for scalar view, vector view, grid view, XY plot. That's currently there. And I can have a figure, I can add it to the frame, and then it becomes visible. And what I was able to achieve was that I can put the event loop and the rendering into a separate thread, which just is made possible by being able to by copying the data into this data structure. VTK gives me some interactivity in these windows. That's just there by their design. Then VTK also gives lots of file output to images, video, or also can just dump the VTK data structure into a VTK file. The API I did essentially is duck typing based, so that I can just integrate this in whatever array code I have in C++. I do memory management using the C++11 shared pointers, so it seems to be quite robust now. I just then also put an C API on top of this, and the stuff builds on Linux, macOS, and on the Windows Unix subsystem of Windows 10. I never really tried to have it on MinGW. Okay, so that's C++, and then Julia just uses the C API I did it just for the purpose of making this available for Julia now. And so I can just load the shared library and use C-call to access the stuff. I tried to modify the API in such a way that it appears to be a little bit more Julian. And kind of nice thing is that I have no pre-compilation time, just loading the shared object. Okay, so let us see what's there. I don't know if this. Yeah. So that's the code now, which we just can use in order to plot a scalar function on a rectangular grid. We open the frame, we can clear it because maybe something else has been there already. Then we create a data set. So now I have a VTKView data set, which wraps kind of the VTKView data set, which wraps kind of the VTK data set, yeah. And I can just create a scalar view. I just make a layout for the frame, just I have one times one layout grid. I can size it. Then I put a rectilinear grid into this data set, and I put a point scalar into this data set. Yeah. And then I tell the scalar, the scalar view, the viewer, this view, that it should use the data, the element named labeled with this V in this data set, and I add the scalar view to the frame. And then I just have this kind of mock simulation code, which just calculates the time-dependent function. And every time I just I created a new value, I just update the point scalar in the data set, and I can display the frame. And that's the way how it goes. Yeah, so that's what comes out of this. And let's just run this for a little bit longer. So we can just, during the simulation run, we can stop it, we can move it around. That's the interactivity. We can also just take an elevation plot and so on. And these things can be essentially use different kinds of VTK filters, which I can switch on or off if I want. Yeah. So, and I can, yeah. Okay, so, oops, okay, so let's stop this one. So, and then we have more primitives. We can have a quiver, just plot the function. And I just also just have another vector for the gradient, which I can calculate. I just can put a point vector into the data set in addition to a point scalar, and make a scalar view and the vector view. And for the vector view, I set a quiver grid, which then users can show the quiver arrows just in the data. Yeah? So I get then two views on top of each other. So I have the quiver and the scalar data in one view, and I just use forward diff to calculate the gradient of the function, and I just visualize this. So, and that's what comes out of this. And I can, for instance, then also just scale the arrows. So there's some kind of keyboard-based user interface which allows to have some more controls, yeah, and then I can run this stuff like this. Yeah? So that's on rectilinear grids. I can also use yeah, okay, there's no thing. So VTK has a built-in Delaunay triangularizer. I use them to just take some kind of random, more or less random point set to make a triangulation to have just testing code for triangular grid visualization. And I can do the same things which I did for the rectangular grid stuff on a simplex grid, or a triangle in 2D on a triangular grid. Yeah. So let's stop this. It was too long. And also can have a quiver. Also on this grid. So okay. So, and then I can have same stuff with a very similar interface in 3D. Oh, so let's have a rect scalar. So okay. Yeah. Well, okay, so I see that essentially Zoom seems to eat part of my GPU, but that's what we can do. Yeah, and So this uses, for instance, in this case, transparent ISO surfaces in order to show 3D visualization data. So let's see if we can, because kind of lost the interactivity for this one. Yeah. Okay. So, so we can move this around, rotate this around as well. And I kind of lost the possibility for interaction. I don't know what the interaction with my GPU here is. And let's also figure out, yeah, I can also have a quiver 3D. Just a short one. Okay. So something has been eaten up here. But you can still see me or hear me. So I maybe adjust, this is a, let's say I have this as a short demonstration. We can also have a layout where we show multiple figures, or let me restart the Julia in this case. And maybe you can see if there's something. Now we see it. Okay. So that's the kind of picture on in the introduction. Now we have the a quiver field. Yeah. I can add the ISO levels. Yeah. And there are also some kind of let's say rudimental possibilities to move the planes around, or to just have an X plane and stuff, or I can just change the size of the quiver arrows and so on. And that's can be done. So, and this is possible on the rectilinear grid, and also can have a simplex quiver. So same stuff for simplex grid, which is considerably slower because of the complexity of this rendering on the simplex grid. And I also have this oops, how do we call it? I can have, oops. This one. I can also just have a kind of trivial layout where I can put different figures together in order to let's say be able to just show several stuff at once. Yeah? So, okay. So what's the state of this thing? Yeah. So okay. So there's the VTK fix stuff, which is the C+ library, which works now for maybe 2 years in a rather robust. Well, just let's say in an okay way. So it's not by far not perfect. So what I want to do is one thread per frame in the multiple frame case, which I didn't demonstrate. I don't have any time for GUI. So probably something could be done based on Qt, because it's kind of integrated with VTK. What I really want to do is to try out the ParaView catalyst, which allows to just have a VTK data set, and then you can send it to ParaView, and you can use ParaView as a GUI interface for this. And also an interesting thing is, which is also missing so far in VTK fig, is in higher order finite elements. So let's say scalar, quadratic, and so on. Quadratic, cubic elements also on 2D and 3D is in particular simplicial grids. So that's kind of part of the wish list. For the Julia thing, it's like still missing some part of the API of the VTK fig. There are some, I can also do stream amps there, and some state toggles are still missing, so it's not that much work to add this. I'm trying to build a GLL. So what I demonstrated comes from a GLL, which I put into a private or my own package nursery repository. which builds this VTK2 and uses, but this only works with Linux because cross-compiling VTK doesn't really isn't really robust with 8.2, but it seems to be much better with 9.0. But still, I need to learn how to export the cross-compilation tools, which VTK compiles for itself to decline codes and so on. So that's the kind of mess to get this running. Yeah? So, but in principle, it should be possible to have it as in GLL. The GLL essentially now hinges on what is available for X Windows, which is still limited to Linux and FreeBSD. And that's not really clear how far this can go. So in particular, also it then starts being quite a bit of work. Yeah? So and then the question is, of course, okay, so that the interface now is, has evolved from just being a completely C++ class hierarchy thing to something which is a little bit more Julian. And I kind of would think about how this can be, just from the syntax, how to access it, can be better integrated into this Julia plotting interface, but that's something I really have no real idea yet, and we will see how this will play out. Yeah. Okay, so thanks, that was it. Yeah. Any questions?
So Jürgen, I had a small question about the functionality of this. Can VTKView plot an irregular grid?
Yes, sure.
So I guess what I was sort of thinking of was twofold. One was if you have an irregular grid of a simulation, do you have to, so you don't have to regrid that, you can just send in a list of points essentially.
So I set in a list of points and a list of simplices. Just the point coordinates and the point numbers of the simplices. That's the interface.
Perfect, thank you.
Yeah. And I can, in fact, I can have more. So in our simulations, we also have just the grids are kind of have sub-regions, and they also have some surface subgrids in order to apply bounding conditions. So in fact, what I can do is with a combined 2D, 3D, for instance, thing also for supplying there. Yeah. But that's not yet in the VTK view, it's just in the C++ code. And yeah.
Makes sense, thanks.
Yeah. So, any more questions? So I'm really trying to make this available. So there are two ways to get this on Linux. You can kind of so I still have some issues with dependency handling in my own registry. Yeah. So I now put this GLL and the VTKGLL into some package nursery repo on my GitHub, but that's not yet working well. So that would be the possibility on Linux. And in general, it's just possible to just you install this VTKView and make your own compilation of VTK plus VTKFig in order to load this then into Julia. You just set an environment variable and then it uses the locally compiled library. But I didn't try this out yet on the macOS X. Yeah, so I would just try to nudge some colleagues of mine to try this. Yeah?